Hello, everyone, and welcome to another episode of the Hidden Quantum Champions. It's time again to dive into the world of quantum mechanics and quantum technology, and in today's video, we are going to look at ORCA computing. Wait, did I really just say okra? Maybe my mind was somewhere in like the Asian cuisine. I was actually not meaning okra as like what you're using maybe to cook some nice Indian dish, but ORCA. It's ORCA computing, and sorry if I mess it up across the video a couple of times. Maybe I was a bit confused. I'm just seeing that after I recorded. And with this, let's jump back to the actual video. So here we are, as per usual, on their website. We see some nice videos running here of computer code, whiteboard activities, blinking hardware, and laser labs. It says changing the future of computing. So you can watch the full video. Of course, we are not going to do that now. We are looking at what the website actually says. So making quantum computing a practical reality. We develop full stack photonic quantum computers to unlock new fields of applications, accelerate innovation, and help transform industries. Our vision is to create both near-term value-creating quantum accelerators and long-term error-corrected quantum computers. We do this through a single technology, ORCA's modular fiber interconnected architecture. By combining novel technology with rack-mounted telecom and optical fiber components, ORCA provides a unique approach to deliver the performance, scalability, and usability to begin addressing use cases such as generative machine learning and optimization. So there's a lot of stuff in that. Let's try to disentangle that quickly. So we are talking about a company that is using photonic technology. So light fibers, lasers, things like this. It says they have two different things they are targeting here. So there's the short-term side and the long-term side. Short-term is a accelerator. So they talk here about quantum accelerators, and long-term is quantum error-corrected quantum computers. So accelerators as in classical hardware interacting or in a closed loop with quantum hardware in order to operate or to run some quantum-inspired algorithms with some quantum elements in there, and then actual quantum computers as a long-term thing. The interesting thing is they use this fiber interconnected architecture, and you can already see here on the right side, it comes in these racks. And these racks, they are like standardized sizes of things that you can see in telecommunications already. So if you look like at telecom communication centers, you have these standard slots where you put in the telecom components, so like the routing switches, whatever. And the stuff that they are doing is actually already designed to like mechanically fit into what is existing and what is out there. So they have this existing technology, and it's scalable, and it can be already started to be used as an accelerator. So on their benefits, they say it's modular and upgradable architecture. So I guess the idea is also that you buy it now, you start to do some experiments, you start to do acceleration, you start to experiment with those quantum hardware elements. So you build these closed loops between classical computers and the quantum hardware. You already do some first experiments and understand how the algorithms work. And then once we are at a point where there's like error-corrected quantum computing, you can basically do an upgrade and you end up with a fully usable quantum machine. Then we have the superior scalability. I think that kind of comes down to the fact that we are using light here, so you don't need cryostats. It's not so complicated in terms of architectural point of view, because you can probably use normal fibers to actually connect the different elements with each other and thereby connect multiple of these compute units. Then it says lower barrier to entry. That's probably because it's modular and you can start with a single module. And then it says a viable commercial path towards fault tolerance. Then we have here the ORCA PT series, an approach to quantum computing like no other. Our mission is to develop near-term industrial applications of quantum accelerated generative AI and optimization. ORCA PT series quantum photonic systems are built on the demonstrated success of real-world applications and deployments in the field. Quite simply, they function, operate, and perform like no other quantum computer and are welcome departure for cumbersome, fragile, and costly systems in the industry. Okay. Benefits of the PT series: quantum accelerated, data center ready, developer friendly, and that's because it says industry standard PyTorch, Python environment, and integration with CUDA-Q, which is the CUDA is what NVIDIA is creating. It's an open source environment that NVIDIA creates for their hardware, and then CUDA-Q is probably the extension to the quantum world of things, where you have like the GPUs from NVIDIA and the software ecosystem from NVIDIA, which is now extended to the quantum side of things. And then it says lowest total cost of ownership from acquisition, deployment to operation and upgrade. And that kind of plays into, I guess, this modular approach when it comes to acquisition, deployment, because it fits in a standard rack. You can put it in your existing server center without having to create a big space for it. And then operation, because you don't have a running cryostat which has to cool, where there's like mechanical stuff moving, and then upgradability again, I think, to the modules. Here it looks like we are looking at the application space. So we see the typical things like networks, molecular, like chemistry, drug development, optimization problems, communication, things like this, artificial intelligence. So I guess that's like where the markets that they try to cater with the system. And then we also have some view here on the leadership, on the people behind the company. There's some news down here. So I'm recording this end of August. You can see there's like a news from August. So this is like pretty much up to date. And then there's some way to contact them here. The company is based in the UK. Now let's quickly check on the technology part. So we see again quantum multiplexing for high performance, a suite of applications for generative AI, machine learning and optimization, inherent network architecture for scale. These are the things that I think we also mentioned before, and that are, by the way, also similar to other photon-based computing approaches. Then the PT series, accelerating your quantum journey. There's some video here as well. Key features: simplify AI and quantum, designed for hybrid quantum classical, and develop your team's quantum readiness. That's exactly what mentioned also before. So you have this closed loop between existing like system and a quantum element, which is actually something that is pretty useful for AI. And if you're interested in this, as always, let me know down in the comments below. We can maybe do a little tutorial series explaining how like classical computers and quantum computers can be used for these AI applications. Then it says like designed for hybrid quantum classical. So this is like where a classical computer is being used together with a quantum algorithm to run some type of application, maybe optimization, whatever. And then of course, that's also one point. Like right now, what they said is like a quantum accelerator, but maybe later on it becomes a fully sustained quantum system. And it's an easy step to kind of get your organization to start working with quantum technology now, because it's an easy, like low entrance, low barrier entrance into the world of quantum. And then you can update it later if you see that like the market is moving. Then there are some articles here that looks like academic papers. Okay, so there's like also some research linked here. Now in terms of products, we see that there's like two products. There's ORCA PT2 and ORCA PT1. Simplicity, practicality and value now and for the future. So again, it's the same promise that we saw before. Okay, I think I'm still at the... Let's quickly check out maybe we start with the PT1 system, because it's probably the basic one, right? So Photonic quantum system, accelerating your quantum readiness. The PT1 is the starting point of your roadmap. There's no need for users to sacrifice immediate needs waiting for technologies to arrive. Rack-mounted, room temperature, and built with optical fiber components, the PD-1 provides access to quantum computing capability now. Okay, so you can see it fits into a standard rack, I guess. It can be used, so it's optimized for hybrid quantum classical machine learning, so you can already start building these hybrid approaches with it. It can be mounted on premise, it's a rack mounted thing, and it's air cooled, so you don't need any like cryogenic cooling for that. Simplified integration with the existing machine learning programming framework, that's the PyTorch related things that I mentioned on before, and lowest entry cost. However, I think there's no specific price here, so we don't know what the entry cost is, and we also don't know, of course, what the competitor's entry cost is. So, but let's say it seems like they have done some market analysis, and they know that like what they can provide is very cost efficient. ORCA Computing to supply 2 quantum photonic systems to Montana State University. So here we see some users, and then we also see here the PSNC, which is also a customer of theirs. Now let's move on to the second product, which is the PT2. So a quantum computer like no other. Rack-mounted, room temperature, and built with state-of-the-art photonic components, the ORCA PT2 provides access to quantum computing scalability now. A welcome departure from the cumbersome, fragile, and expensive systems, the PT2 is built on the proven success of real-world deployments, represents a significant leap in the capabilities and performance from its predecessor. Our most advanced photonic quantum system, the ORCA PT2, functions, operates, and performs like no other. So here now it says we are looking at something that is more reassembling a quantum computer. So here we are moving away from this very specific task of, let's say, hybrid implementation, probably towards something that is more into quantum computation. It also says here built for AI and HPC environments, ORCA PT2, the engine for hybrid quantum applications. Now AI, I think, is not, let's say, the only task that you can do in quantum computing. And I think if I look at this, like here it says quantum computer, here it says AI, it looks a bit like in the first moment it might be a bit counterintuitive. Of course, there is AI applications that are, let's say, written in a quantum way. And that's probably what this is targeting. So it's using the function, like the way that quantum mechanics works to do machine learning tasks on top of it. So it's possibly using, for example, the Hilbert space to actually perform some optimization in terms of machine learning in it. Here it says the engine for hybrid quantum applications, high performance photonic and computing, ease of integration, developer friendly, data center, and AI factory ready. So here it also targets AI factories. AI factories are large compute centers that are really catering the application of AI, so machine learning, big supercomputing centers with a lot of machines in there. Then we have quantum accelerated generative AI and optimization, and then low total cost of ownership again. We see also here that we have some customer feedback on here. There's also the NQCC, so in the UK. And we also have here, what do we have? Quantum experts join forces to revolutionize European quantum computing. So here we see the Niels Bohr Institute mentioned in there. So it says supported by Eurostars, a European funding program, ORCA Computing, Pixel Photonics, Sparrow Quantum, and the Niels Bohr Institute are collaborating to deliver a full-stack photonic quantum computing system. Very interesting, and definitely looking forward to see more of this in the future. Now there's some stuff here on the applications. As mentioned before, let's quickly go through the main categories that they are targeting here. So there's energy, optimized renewable energy production, response time and lower resource costs, chemistry, healthcare and life sciences, so drug development, transportation and logistics, that's like into the direction of the traveling salesman problems or optimization problems, which also says here operational efficiency. There's defense, optimize operations, enhance observational capabilities for strategic planning and leverage, enhance anomaly detection. So that's like an AI task or a machine learning task, anomaly detection. And then we have manufacturing, which again is a optimization problem, accelerate manufacturing in automotive and aerospace industries with a range of use cases from materials to logistics. Okay, materials is of course again like quantum chemistry. Then we have some other stuff here, quantum accelerated Gen AI, combinatorial optimization, AI factory, and high performance computing. And then there are some articles again down here, news articles linked to this. Now let's also quickly check out the company part here. We see making quantum computing a practical reality. That's the mission of the company. Headquartered in London with offices in Toronto, Canada and Austin, US, we develop and provide full-stack photonic quantum computing systems to address applications of scientific and economic importance. Funded in 2019 as a spin-out of the University of Oxford, ORCA leverages over 30 years of scientific research and technology breakthroughs by co-founder Professor Ian Walmsley. The company was established to deliver a completely new approach towards photonic quantum computing. Since our founding, the company has enjoyed numerous achievements, including leading a record £11.6 million quantum data center of the future grant from the UK government and delivering 10 on-premise quantum photonic systems to customers around the world by early 2025. Customers such as the UK Ministry of Defence, National Quantum Computing Centre in the UK, the Poznan Supercomputing and Networking Centre in Poland, and Montana State University in the US have placed their trust in us to advance their quantum technology process. So also some renamed institutions that are already working with this. Our mission is to make quantum accessible and bring the potential benefits of quantum to reality. And that's very aligned with us. We also want to democratize education around quantum technologies. So that's also part of this format, to make knowledge around it accessible, to show you what are the companies out there that are working in the space of quantum technology, including, for example, that one here. And with that, I think we are already getting to the end. There's some knowledge hub here, which I think collects all of the different media materials. So there's news, there's podcasts and videos, probably with coverage on the company. There's some reports and publications, and there's also, again, an event calendar where there's all the events that you can actually meet ORCA Computing at. With that, I thank you again for tuning in for today's episode. If you liked it, please make sure to subscribe so that you don't miss out on the next one. As always, make sure to stay hydrated and see you by then. Bye bye.